this video I'm going to be specifically making it for the M105 classes at IUK. These are concepts out of section 7-4. We're going to take a look at adding and subtracting radicals that first require simplification. Alright, as you recall in an earlier video, I stated that if you were going to add or subtract radicals, they had to be like radicals. Now we're going to take a look at problems where what's underneath does not match. So we need to first simplify these radicals to try to create like radicals before we are going to be able to add or subtract them. Alright, so basically what you need to do is start with the first one, simplify it, start with the second one, simplify it, and hopefully you will get down to like radicals. Alright, the way I simplify my radicals is I split everything up. Alright, that 4 is just going to stay out in front. Okay, then I'm going to take that square root of 27. I'm going to come up with the biggest square root that goes into 27. Okay, so biggest square root that goes into 27 is going to be 9. 9 goes into 27, and it is a perfect square root. So I want to use 9. Alright, 27 divided by 3, or divided by 9 is 3. Alright, so doing this, that's going to make breaking up that 27 the quickest I possibly can. 9 times 3 is 27, so I know I've broken it up correctly. Alright, then I'll have the square root of x, which I can't do anything with. Alright, I'm going to keep going all the way down on this one before we finish out there. Alright, so we know that the square root of that 9 is 3. I still have the 4 out in front. Square root of 9 is 3. Alright, these two things I can't simplify, so at this point I could go ahead and go square root of 3x right there. Multiplying these things out in front, I'm going to have a 12 square root of 3x. Alright, now we're going to break up this one the same way. I'm going to have the 8 that's sitting out in front. I want the biggest square root that goes into 12. That's going to be a 4, so I'll have square root of 4. And then 12 divided by 4 is 3, so square root of 3, and then we'll have the square root of x as well. Alright, now, this one, I can take the square root of 4, which is a 2. That 8 is still going to be there. The square root of 4 is 2. Alright, and at this point I cannot simplify either one of those, so I can just go ahead and write it as a square root of 3x. Multiplying these two things out in front here, I'll have an 8 times 2, which is a 16. So minus 16 square root of 3x. Alright, I now have like radicals. So I can go ahead and do this left to right. Subtracting these, 12 minus 16 is going to give me a negative 4 square root of 3x. Okay, coming over here to this example, I'm going to have 2 times the cube root of 16 minus 4 times the cube root of 54. So we need to do the exact same thing. I need to find the biggest cube root that goes into 16, the biggest cube root that goes into 54 to be able to break these down. Alright, now, as I've shown before in some of my videos, alright, for those students that are in my 105 class, you can go to my website, you can download this chart. If not, you can Google it. It is a chart of perfect squares, perfect cube roots, perfect fourth roots, and perfect fifth ones. Alright, so if I'm doing cube roots, I'm going to go down the cube column here. Alright, 1 goes into 16, yep. 8 goes into 16, yep. 27 is bigger than 16, so it does not. So that means the biggest cube root that goes into 16 is 8. Okay, so we'll go ahead and leave that there. So the 2 is going to be out in front. Then I'm going to have a cube root of 8. Alright, 16 divided by 8 gives me a 2, so that means I have to have a cube root of 2 right there, so breaking that up. Alright, let's go ahead and break up this and then I'll work from there. Minus. Alright, this 4 is going to stay out in front. Okay, now I got to break up this cube root of 54. So again, I'm going to go down my cube root column here. Alright, 1 goes into 54, 8 does not go into 54, 27 does go into 54. Alright, and then I get to 64. 64 is bigger, so then that means the biggest cube root that's going to go into 54 is going to be 27. So I'm going to have a cube root of 27, and then 54 divided by 27 is 2, so cube root of 2. Alright, now at that point I have done my simplifying there, so let's just keep going here. Let's put a little thing there so we separate this. Alright, so 2 times cube root of 8 is 2. And that cube root of 2, I'm just going to leave because I can't do anything with it. Alright, going straight across here, I'll have 4. Taking the cube root of 27, cube root of 27 is 3. And then times that cube root of 2. So at this point we can already see that we're going to have like radicals. Multiplying these two out in front, I'll have a 4 cube root of 2 minus 4 times 3 is going to be 12. So then I'll have a 12 cube root of 2. And then I can actually go ahead and subtract these two. 4 take away that 12 is going to give me a negative 8 out in front, cube root of 2. So definitely, it's going to take some space here to write this out, but if you write this out and break each one of them up so that you can see everything individually, I think you're going to be better off. Okay, let's go ahead and do some more examples with some variables and some little polynomial, binomial expressions here. Okay, so for this example, all right, I've got some variables with exponents underneath. Okay, I've already got cube roots on both of these, but the part that's not matching again is what's underneath, so that's the part we've got to fix. All right, now looking at this one, all right, I cannot simplify the cube root of x, and I cannot simplify the cube root of y squared, so I don't have to do anything to this first term because it cannot be simplified. So I'm just going to go ahead and write it down. Let's go ahead and move it all the way over here. 5 times the cube root of xy squared. Alright, which means now I've just got to focus on this. Alright, now this is going to be a nice one because I'm going to show all my steps here though, but cube root of 8, we know that's 2. Alright, I'm going to go ahead and break it up and leave it for right now as the cube root of 8. Okay, now, what I do here, I cannot take 4 divided by 3. Alright, so again, from previous videos and what we had done in section 7-3, alright, start with your 4 exponent and start going down till you find something that divides by 3. Alright, well, I don't have to go very far. X to the third, 3 divides by 3, so I can break that up into the cube root of an x to the third. If I've used 3 of the x's, that means I have 1 x left over. Alright, and then same thing with the y's here. Okay, so I've got a 5. 5 does not divide by 3. I go down to a 4. 4 does not divide by 3. But if I go all the way down to 3, it does. So then I'm going to have a cube root of y to the third. I've used 3 of those y's. That means I've got 2 left over. So cube root of y squared. Sorry, I think I didn't say that. I've used 3 y's. I've got 2 left over there. Alright, now this, like I said, stays the same. We're not doing anything with this. So x y squared. Alright, now let's go through here. Cube root of 8 is 2. Alright, 3 divided by 3 is 1. This is a perfect cube root, so that's going to give me an x. I can't do anything with the cube root of x right here, so I'll have the cube root of x. 3 divided by 3 is 1, so that means this is a perfect cube root, so I can pull out a y right there. And then this I cannot simplify, so I'll have the cube root of a y squared. Alright, now on this term over here, keep in mind we're just working with everything to the right of that plus sign, trying to simplify just that second radical there. These 3 things have been pulled out, so I'm going to put them together on the outside. I'll have that 5 cube root of xy squared. Alright, so 2 times x times y on the outside, and then underneath, these are like radicals. I can go ahead and multiply what's underneath there, so I'll have a cube root of an xy squared. So now I've got them down to a cube root of xy squared, so I can put these 2 terms together. Now, these are not like in the past we've had just a number here and a number here, so I've been able to add those 2 numbers. I cannot actually add these 2, but what I can do is I can put them together in a set of parentheses showing that I'm adding them. The parentheses are extremely important, so I can do 5 plus 2xy showing that this quantity would be added, alright, times that cube root of xy squared. Alright, if you leave that set of parentheses off, it changes it completely, because then you would be taking 5 plus 2xy times this quantity. So showing that you're adding those 2 together there in front is going to be extremely important on that one. Okay, now for this last one here, alright, it looks like at first glance that, well, you're not going to be able to do anything with it. However, you do have binomials here. This is a binomial, and if you look at it closely, you're going to be able to take out a greatest common factor. Okay, so let's put GCF under there, just so we kind of remember what we're doing here. I can take out a 9. All right, so, and leave it underneath the radical. I'm just working with that binomial underneath the radical. Factor out that 9. That's going to give me an x minus 2. All right, and then I've still got the x minus 2 over here. All right, now, still don't have like radicals underneath, but square root of 9 is a perfect square. I'm going to go ahead and show the breaking up here. Square root of 9 times that square root of the x minus 2 plus the square root of the x minus 2. All right, we know this is 3. So really, this simplifies to 3 square root of x minus 2 plus square root of x minus 2. I have my like radicals here. Don't forget there is an imaginary 1 sitting right there in front of that radical. When putting these together, I'll have a 4 square root of x minus 2. All right, so basically just 4 little examples there of showing how you've got to simplify your radicals first to create those like radicals, and then you are able to add them. Definitely thanks for watching. If the videos are helping, don't forget to share with your friends and subscribe to the channel. Thanks.